Hello and welcome to a Chapter 7 practice problem. This problem looks at a question similar to question 31 in Chapter 7, finding the area between two z-scores for a proportion. The problem we will be working with in this video is, a retail president believes that 45% of a company's orders come from first-time customers. A simple random sample of 100 orders will be used to estimate the proportion of first-time customers. So what we need to do is assume that the president is correct and P does equal 0.45. The problem will ask us to find the sampling distribution of P bar for this study. And secondly, we need to find the probability that the sample proportion is between 0.41 and 0.46. So before the problem, we need to define our terms. Our sample size, or N, is 100, and our population proportion is 0.45. Next, we need to prove normal distribution. In order to do that for proportions, we need to prove that n times p is greater than or equal to 5, and that n times 1 minus p is greater than or equal to 5. For a proportion, both of these must be true to prove normal distribution, or if one of these is false, our data is not normally distributed. So part A is asking us to assume that the president is correct and P bar does equal 0.45. What is the sampling distribution of P bar for this study? So in order to do that, we need to check normal distribution. So we have our checks here, n times p being greater than or equal to 5, and n times 1 minus p being greater than or equal to 5. And then we have our data, our n and our p. So to check, we plug in our terms to the check, so we get 100 times 0.45, which is equal to 45, and 100 times 1 minus 0.45, which is equal to 55. So because both of these are greater than 5, we know that our data is normally distributed. And as part of this, we need to calculate our standard error as well. So I have the formula up here in the corner, and I have it right here as well. So our formula is the square root of p times 1 minus p divided by n, multiplied by the finite correction factor if we're allowed to use it. And in this case, we are not allowed to use the finite correction factor because we are not given a population that our sample is taken from. So in that case, it just leaves us with the first part of this formula, and when we plug in our terms, we get the square root of 0.45 minus, or times 1 minus 0.45 divided by 100, which gives us a standard error of the proportion equal to 0.0497. So for part B, it is asking us to find the probability that the mean of the sample proportion is between 0.41 and 0.46. I put the formula for the standard error of the proportion up here, and the z-score formula adapted to this problem up here in the corner as well. So before we go any further, are we allowed to use the finite correction factor in our calculation here? Well, it turns out, no, we're still not allowed to use the finite correction factor because just like part A, we are not given a population that our sample is taken from, so we're not allowed to use it. So, just like part A, we need to calculate our standard error. So we have that right here, the part of the formula that we can use, plug in our terms, get the same thing that we got in part A. Next, we need to find the z-scores for the 2 points that we're looking for. The first z-score we are looking for is for 0.46. So we have p, the point that we're looking for, minus p bar, 0.45, divided by our standard error of 0.0497, which gives us a z-score of 0.2, which has an area to the left of 0.5793. Next, we need to find the z-score for 0.41. So we have the same formula, plug in 0.41 minus 0.45 divided by 0.0497, which gives us a z-score of negative 0.8, which has an area to the left of 0.2119. So to find the area between these 2 points, we need to take our larger area and subtract our smaller area. So that gives us 0.5793 minus 0.2119, which gives us an area between the two z-scores of 0.3674, or a 36.74% chance that the mean of the sample proportion falls between 0.41 and 0.46. So I hope this video was helpful in explaining this concept to you, and I will see you in the next video.